Okay, so I'm going to be talking about today is our custom remote controller. So welcome to everybody to the meetup. We few people joining today, so we had another kind of 100 people join the meetup. I think we're up to almost 1,200 now, which is great. So I'm Godfrey Nolan. I work at a company called Reese LLC, which is in Detroit, Michigan. What news do I have this week or this month? Well, there's tariffs are causing kind of lots of confusion here in the US, and it will have some impact on the pricing of the remote controller. I do have a bill of materials, and we were just saying that it looks like AliExpress is actually denying any sales to the US and letting stuff into Canada. And also the prices are going to go up, of course, because of the tariffs. That's kind of a moving target. So I don't actually even know if it's 25% anymore or if it's gone down to 10%. I don't know. So my bill of materials is a bit out of whack, but I will fix that. What other news do I have? There's no more news on the DJI ban that I've heard. Kind of way it's gone from the House going into the Senate. I kind of expect that to happen in the next month or two. Who knows what's going to happen though? Whether it's going to be a huge change or just a rolling change. If there's no ban next month, I'm probably going to have a look at the Mavic 4e because it's got some really good AI stuff that I want to look at. So you can upload a couple of models. So we'll probably do that, and then also Francesco Gadaletta, I don't know if hopefully I pronounced his name correctly, from Intrepid AI, has got a new ROS2 simulator that works with PX4 drones. So he may be doing the talk in May, and if not, he'll be doing it in June. And if anybody else wants to do a talk, you're more than welcome to do a talk on anything related, drone related, DJI, Autel, Parrot, don't mind. The main thing is just don't want to spam the audience too much. So that and there's everything that we talk about here is a bunch of links in the resources for you to follow. Kind of we're giving away as much as possible, so I've kind of borrowed it for everybody else anyway, so it's not like we're giving it away, but it's we just collected it all together. So if you want to download the STL files, you can download the STL files if you want to play with this stuff yourself. Okay, so what are we trying to do? So here's the in a custom handheld remote control device. So what I want to do is to have a super bright screen, and I want to have control on all the components that are in there, so I know what's in there for obvious reasons, for NDAA reasons here in the US, or just to, for pricing, for lots of different things. There are quite a few remote controllers out there for the drones, for PX4. This one I'm using is Windows 11, but of course it could be Linux, it could be Android. It really just depends on what. But essentially, I just want something that's a little bit different from the HearLink. Not that I'm picking on the HearLink, but the HearLink is using Android. It's an old version of Android, so I just, there are some limitations with some of the stuff out there. So what are the 3D printable housing? I know I've told people in the meetup before that we got a new 3D printer. I'm really into trying to 3D print as much of the drones as I can. So the remote controller seems to be the first place that would make sense to do that. So we want to make sure that we're printing the controller. A couple of our customers, I saw that a lot of the proof of concepts of their controllers were 3D printed. So we're trying to do that. In this case, I wanted Windows 11 capable hardware, but that could be anything. It could be, maybe I want to run it in Linux. Maybe I want to run it on, so I've got to let some more people in. I want to run it on, we're up to 20, yay. I want to run it on a version of Android, a newer version of Android that's currently available. So, but in this case, I'm just Windows 11. I want a super bright touch screen, and I think that's the most important thing here. So a lot of the touch screens that are out there just aren't what you need for flying a drone in, outside, because they're just not bright enough. So the Google Pixel phones are kind of useless. A lot of the RCs out there, we've been deck and a few other, they're just not bright enough. They're 500 nits, And what I'm looking for is, well, the one we have here, I think is 2400 nits. So, you know, significantly brighter. So this is the, let me show you what the screen looks like. You just go back a couple of slides. So this is what the screen looks like. It's orders of magnitude brighter than what we have for a just using a Google phone. So instead of you needing to have like a housing that covers it, basically we just have a super bright touchscreen. I wanted to have analog joystick and button inputs, and then unfortunately I didn't finish it, so we are still using kind of an external power source, and the telemetry radio is not part of the but there's no reason why it couldn't be. So future revisions of this would be, you know, we'd have an internal battery and then a built-in radio, but we're pretty far. We had a lot of fun. So what's the motivation? So the motivation is to the limited options that I find out there. So we have the HearLink, the Taranis. There's a couple of CEs, I think, as well. The UXVs, how do you say it? The SRock. And then there's the FreeFlight Pilot Pro and a lot of the ones out there. Some of them are expensive and some of them are outdated. And, you know, there are tons of hacker things out there that get us part of the way. And I just wanted to see if I could get a little bit further and put everything together so that to give you the options for, hey, if you want to run Windows 11, do this. If you want to run Linux, do this. And if you want to run Android, you can do this too as well. Sometimes there's limited availability too as well. I do remember in the past, we were trying to buy some, this was before COVID, trying to buy some RCs. We just couldn't get them just because they were gone to different people, just couldn't get them. Android only. I do a lot of Android, but what happens if I want to do something else? If I don't do Android, or if a customer of ours wants to. And then so Linux, nice segue to Steam Deck. So Steam Deck, good device, or the LIX, the ROG LIX. But unfortunately, they're only 500 nits, so they're just not bright enough for what we want. And also, Steam Deck really doesn't seem to be that keen on having people using their Steam Decks for drone RCs. So I know there's been some pushback too as well. And then I did want to think about NDAA compatibility. So when I look at these, you know, tons of arguments about which RC is Blue UAS and which one's not. I'm sure you followed all the stuff that happened on LinkedIn, but what better way to know what's in your RC than to build it yourself? There's also projects out there like the NUC deck, which has shown how that's really possible to create custom handheld hardware. It's mostly for gaming, but there's no reason why we can't take that and use it for our own needs. Okay, so what are my tasks here? I got 3 major things to do. So what off-the-shelf components can be found to meet our requirements? And then how can we use joysticks and buttons as inputs? You know, I'm a software guy, I'm not really a hardware guy. So we have a new hardware guy, Ben, who really helped me out in this. Hats off, Ben. And I wanted to know how you get the custom joysticks and the buttons to interact with the tablet or the just the screen that we're using. And then how will we house everything? So we need a display and a small main board. So we also need buttons, analog joysticks, and an Arduino. We're going to use an Arduino. So we're going to use the Arduino as the HID device, the human interface device. And then we're going to mount everything in custom PCBs. I'm not a huge fan of just soldering everything all over the place. So we wanted to get into do a bit more of designing and making our own PCBs. So I thought this was a good way of doing it. So, you know, we'll share how we did that and who we got to do it with. How will everything be housed? So we need to design a 3D printable housing. One of the reasons that we were really into doing it with just 3D printing is, well, first of all, we got a new 3D printer, so that was great, a Markforged. And then the second thing was that Steam Deck have released the STL file for their Steam Deck, so I thought it's great, maybe we can use that. In the end, we didn't actually use it, but it kind of was the motivation for how we got here. Okay, so our main NUC, a newest unit of compute. So they sell really small PC, normally housed PCs, but they also sell the board on its own. So it's a perfect size for a project. So many different CPU options, lots of RAMs, Wi-Fi modules, all the other stuff. The we bought this from AliExpress, but I was looking up the Asus, and they're based in Taiwan. So I don't know if it's NDAA compliant, but it would definitely be something that would be worth looking at or doing a proper audit on to make sure. So future versions, we'd kind of have a thinner laptop fan. The second one was this display. So we're using a display that we got on Ali. So it is significantly brighter than a typical phone or laptop display. And then it also comes with a controller which has HDMI input and USB power input, touch output. The other thing as well is that the displays don't have to be NDAA compliant, from what I'm gathering. I am not a lawyer, but that's what I found on the websites today. So, we want to make sure that we're looking at the things, sourcing the things or trying to source the things that are most important and try and make sure they're NDAA compliant. Got to tell you, we're nowhere near that yet, but that's really what our aim is in this exercise. Okay, the next things that we need are Hall effect joysticks. So they're kind of for our replacements for our game controllers. The ones we got were pretty cheap. You could kind of swap them out with more expensive modules. We want some tactile buttons, some squishy buttons to make sure that this is clicky. And then we're going to use Arduino Pro brain part of this ORC. Kind of reads the two joysticks, which are the analog inputs, and the buttons, and passes them to the main board, acting as a USB gamepad or mouse. And then there's lots of existing Arduino libraries out there, which means that we don't have to do any hard work. Basically, what we're doing is just putting components together, which is always my favorite thing. And we are giving away all the code, showing all the libraries that we've used. So if you are looking for that, it'll be at the resources at the end of these slides. Okay, so basically the reason that we're using Arduino Pro, and I know that's not NDAA compliant, is because it means that we could just use existing libraries and we don't have to worry too much about interfacing our joysticks and our buttons to our NUC. Okay, we also need a switch, so that's gonna toggle the inputs between mouse and gamepad mode, a bunch of connectors, and a bunch of fasteners. And the fastener is really just to cheap and cheerful for our 3D printed. Okay, so this bill of materials. When we do the blog, I will update this. So we have our display that I just showed you. We have our NUC. We have our power supply, SSD, RAMs. A lot of this stuff coming from AliExpress. For every was $700. Probably would definitely have to redo this at the moment. That's kind of a moving target based on the tariffs. A couple of things have happened. One, AliExpress is not allowing us to, as I said earlier, buy stuff from the US. It's not really a problem for us because we can get it in Canada just downriver from us, and then but it will be if you're big. I have to see if I can figure out a way which is not using AliExpress and using something else. So the costs are going to go up. The tariffs are also going to have an impact. So it's probably going to take me a couple of weeks to get this in a state where it's kind of like a more accurate target. Another thing that we found that was really important is for the main components, well, almost for everything, you really want to order double, because we had a couple of significant failures when we were doing this. Power supply and the display didn't work for us. Some of the buttons we had to replace. So especially if you're in a time crunch, just order twice of whatever you have, and hopefully you can get to have at least one of them working. Okay, so task 2, together our custom joysticks and buttons. So we're using our Arduino Pro Micro as our HID. That's a human interface device. So that's our keyboard, mouse, gamepad. We're going to connect our analog joystick inputs, the buttons to digital inputs, and then we need to be able to toggle between the mouse and the gamepad mode, and send the joysticks and button inputs to the main device. So here are the components that we bought. Here is the grip that we 3D printed, and here's the PCB that we designed and got somebody else to print. Okay, get into that a little bit further in a second. Oh yeah, what else did I want to say? So the HIT device that we're using doesn't need custom drivers for standard functionality, and will work with kind of all modern operating systems. We're using Windows 11, so that was great. So basically, we're telling it it's a gamepad or a mouse, and it's connecting it, and it automatically, because we're using the kit that we're using, recognizes that it's talking the right protocol, and we don't have to install any more drivers to get the game. So that really helps a lot. Okay, so let me show you what the code looks like. So I always want to talk about the code. So this is our bunch of different links that are in the resources. So the first one is, here's all the code that we basically used. We had okay, what else do we have? No, is it messing me up again? That's not good. Yeah. I think I'm doing too much. Let me see. Okay, let's go back to this. So you have access to the code. You should be able, it's the gamepad.ino code. As we have to include that we're using. We have to do our joystick calibration, our pin mappings, for our buttons. So we have to tell it which button it is. We have a scroll delay counter, so that's a counter to manage the scroll delay for smoother scrolling. And then we have, maybe I can show it to you in visual code. Maybe if I do that, let me try that. So I do actually want to show the code. Why is it not coming up? Okay. All right, so yeah, this will work just as well. Try that again. So we have our include libraries at the top. So this is the joystick library that we're using that works with Arduino. So we're basically for pin map, we have our button indices, we have our input settings. Just setting up the joystick to calibrate the joystick. We have a map function, so we can make sure that it's always going to get back to the center when we're moving the different buttons. We have our analog conversion functions. So converts analog joysticks reading to the HID values and the mouse values, and then the scroll wheel values. We have where are my utility functions? So we have a couple of utilities that will wait until a button is released and wait until a button is pressed. Our calibration functions are calibrating the left and right joystick. We have a setup function, which is just set everything up. And then we have finally the brains of what's going on, which is our main loop here. So our main loop checks if the joystick buttons are pressed to start calibration, reads the state of the switch to determine what's going on. So if it's a mouse mode or joystick mode. So if it's a mouse mode, it converts the joystick inputs to mouse movements and scroll wheel actions. And then if it's joystick mode, it converts the joystick inputs to joystick HID values, so the human interface again. And then we send the joystick and mouse states to our Arduino, and Arduino takes care of it into our Windows 11 machine. It just thinks that it's using the joystick connected to a laptop, because our NUC is essentially a Windows 11 laptop, and although we're using a 3D printed joystick, it's still just a joystick. Okay. Enough of the code. All right, so custom circuit boards, I'm a huge fan of, because they allow us to cleanly mount our components and connect them electrically rather than just having tons of wire going everywhere. Do is design a couple of simple circuit boards that don't, mean that you have to spend a ton of time getting trained in PCB design. A couple of hours on YouTube tutorials to get you going. So in our design, we have two PCBs. The left one needs a small PCB to mount the left analog stick, and then the right one will mount everything else. So it's got the right analog stick, it's got 4 buttons, a switch, so we can switch between mouse and gamepad, and then the Arduino itself, which is here. So it's the Arduino Micro Pro. And then we need to collect the 2 circuit boards together, and then we have some mounting holes so that we can be fastened to the 3D printing housing. So we used KiCad, K-I-C-A-D, which was used for designing this. So what you do is you start off with the schematic here. So basically we put whatever components being used. We can test the circuit within KiCad, and then we move on to the layout in the center. So we're designing the physical layout. So here's all the bits that we want in it. Here's the physical layout, which matches what we need to fit into our housing, which we just saw a second ago over this side. And then this is finally on the left-hand side, we have the physical layout of the board. And then we export this design and we upload it to a PCB manufacturer. And that's another thing that I need to figure out whether that is NDAA compliant. It's JLC PCB, who are the ones who did this. I suspect we're probably going to have to find somebody local, because the shipping was more expensive than the actual PCB design. So then now we want to design the 3D printable housing. So there's lots of different tools out there for you to do this. You can use the NUC deck if you want to use their designs. You can go to our website and borrow our design, but whatever makes sense for you. So when we were doing this, we wanted to split it into multiple parts. So we have 1, 2, 3, 4 parts altogether. I think it's 6. 1, 2, 3, 4, 5, 6 parts altogether. So we're actually going to update that now because we have a larger print bed. So we're going to see if we can do it in 2 parts. But for the first revision, it basically comes in this shape. I have shared this file. So if anybody creates their own Onshape account, they should be able to use this. So you can see that we have, housing for our buttons, housing for our joysticks, housing for a switch. This is where our display is going to go, and we have enough room in the bottom to be able to print it out. So and we do have some supports in the inner surfaces. Did kind of public available, but there was just so much on it that it kind of makes more sense to just do your own. And if you have any experience in 3D printers or 3D design, this is pretty simple design. When we updated, okay, so when did I cut out? 5 seconds, 10 seconds? Okay, so what I was saying was we did really consider using the Steam Deck design, which is publicly available, but we ended up just doing our own custom design. Steam Deck had too many things going on with it. So if you want to start using, I think that's a good place to go. If you want to use the NUC deck, I think that's another good place to go based on what your needs are. This is kind of an ever-evolving thing. At the moment, we have 6 pieces. Like I said, I think it's going to get down to 2 pieces in a couple of days. We're already trying to do that. Okay, starts with circuit boards and grip. All components need to solder to the board. So this is really the only soldering that we're doing, or soldering, as you say here in the US. So wires are soldered between the boards to connect them. Circuit boards are then fastened to the left and right of the 3D printed grips. Then we have the button, joystick rings, and switch are placed into controller faces. The joystick rings, which are the orange circles, are glued into the frame. Switch and buttons fit loosely into place. And the next thing that we need to do is get our grips and controller faces fastened together. So we have the 2 sides together. It's just basically screws. I like the fasteners that you can use in 3D printed. So the ones that you indent into the plastic seems to work really well for us. And then the micro USB ribbon cable is to connect to the Arduino cable, which we will do later. So next we have the display. So this is probably the simplest part. So the fastener points are just shown in red. The display are taped when we get started. Here's what it looks like in real life. Excuse me. So this is the display that we bought off AliExpress. And then we have the HDMI ribbon cable for display and the USB-C ribbon cable for power and the touch input. Okay, the next piece that we have is we want to put the NUC board, our computer, into the back frame. And then essentially screw it into the 4 corners. Finally, everything with 4 screws in the back. And if everything looks well, so at the front of the device, we have to plug in the HDMI ribbon cable to plug it into for the display. And at the rear, we have to plug in the 2 USB ribbon cables for the display board, the power touchscreen input, and the Arduino. And this is what the final product looks like. Okay, so if we want to, let me just show you, see if I can show you a video first. I have a couple of videos that I wanted to show. Okay, so when we're all done, this is what we've got. We got a Windows 11 box, which is acting as a gamepad. There are a couple of setup things that we need to do in order to get this. But even there, I think you can see that the screen is super bright. Okay. Okay, we want to set up the device. So setting it up, we need unfortunately a 19-volt power supply for the NUC to get that working. Gonna add batteries in the near future, so we don't have to do that anymore. You have to install Windows 11, no different from installing when you're using a USB onto your laptop. We have to install the missing drivers. I included a link for that in the resources. So there's Intel drivers that we have to install, no different than if you're setting up a new PC. The NUC board, the one that we're using, doesn't have an antenna built in, so you have to buy one, which make sure that you have put it into the Wi-Fi. Sorry, you'll need to buy one and a mounting piece with your Wi-Fi card if you want to have the Wi-Fi connection. And then since the HID protocol is so widely supported, no additional drivers should be needed for the Arduino to be recognized as a mouse or gamepad. If you do, then I suspect that you're doing something wrong. Point held Windows QGroundControl to just download it and install it as usual. So then, so what do we have here? So in this case, what we're doing is we have, this is a Hollybro radio that we're connecting to it so we can connect to the drone. And then we have, this is our unit here, and we were doing this either when the screen went out or before we had the screen working properly. Let me show you the video for this. Okay, so a drone was nearby with the telemetry radio attached. And then the other telemetry radio, as you can see, is connected here. The ORC is being powered by wall power. No mouse or keyboard was used, only the analog stick and buttons were here. QGC started up. The switch toggles between the mouse mode and the game mode controller mode. So in the first position, the left stick moves the mouse and the right scrolls. And then in the second position, the buttons act as left, right click. So the main thing that you have to do in here is that you have to calibrate the joystick. Hold on a second, I could let somebody else in. Okay. And as you can see that, so you can put an action to count. And then we want to make sure that we're calibrating the joystick. So basically this is just working through how we're going to make sure that we calibrate the joysticks. Very cool. I will say we had a lot of fun doing this, and I think it's going to continue to be an entertaining project for a few more weeks just yet. Okay. Almost there. Did show you what it was like to run the brightness video. And then finally, we just have a small video where it is where the drone is flying. So I'm just going to start that real quick too as well. This was done today. We were waiting on a new screen because the screen did flake out on us. Like I said, if you're going to buy this, buy a lot of these components, just make sure that you buy doubles. It's a pretty windy day today, so the drone's gone all over the place. But just did want to show you that it actually works with QGroundControl. So we have QGroundControl off the left-hand side. Okay. Okay, so what improvements that we're going to make in whatever next versions we have. So we're going to add internal batteries. We're going to use a built-in radio. So whether that is an NDAA one, so like a micro hard or a Doodle Labs maybe, and then add more buttons. So I think we need some bumper buttons. Maybe if we could add a camera, turn it upside down, flip it upside down. The different button layout. I think when we were playing with this, we found that the layout was good for gamepads, but not good for controlling a drone. So we're going to move the second joystick up so that it's level. Use a larger print bed to print as fewer parts. We're already started to do that. Use a smaller NUC board. So there are several different NUC boards that we use. So we're probably going to go with a smaller version. And then always order multiple parts. We had a number of components failed, so it's a good idea to order multiple parts. So I was looking up some of the stuff about the NDAA over the last few days. So this is in the EU, sure that each are not from China, essentially. So therefore, if you want to go, potentially go to have your drone as a blue UAS, the ORC has to be part of that. So we need to make sure that the flight controller, the thing that's controlling PX4, is NDAA compliant. That's on the drone. So I'm thinking something like a Blue Cube radio. So that would be a micro hard or Doodle Labs. The data transmission's important. The camera, so like a Gremsy or something, a gimbal, GCS. The OS is Windows 11. I'm thinking that because the Asus is a Taiwanese company, that we may be able to get away with that, but I haven't done a full workout on everything because I don't know what chipset it's on the NUC. I'd have to do more of an audit to make sure that they were sourced in Taiwan. And then the resources. So here are the resources. So we have the KiCad for designing our PCBs. We have the JLC PCBs where we order them. We have Onshape, which is, this, whether you use Fusion or Onshape, it's up to you. But the Intel, where we have all the drivers that you need to have on your Windows 11 box. This one here is the code that we're giving away. And then NUC, which I think is really cool, is partly some of the inspiration, motivation that we got for doing this. So this is a 3D printed game controller. So I'll show you what that looks like in a second. And then there's a really good one that we found as well, which is printables, which goes through in excruciating detail all of the stuff we've done today. So if you don't like our design, then I strongly recommend looking at some of these other ones to get you started. Okay, so let me just show you what this is. So we have our files here. If you want to copy what we've done, they're in .3mf, but it's pretty easy to convert them to STL. We have the code that I was just going through. We have our design from the PCBs, if you want to do that, if you want to check out what's going on there. This is the Onshape that we were using. Export a civil file to whatever you want to use, whatever you're more comfortable with. This was our KiCad for designing our PCB, really straightforward. Some great learning YouTubes will get you started there. This is our JLC PCB. So it cost us $15 to get this. To print our PCBs, like I said, it costs more in the shipping than these. This is NUC Deck, and UC Deck, which I think is a really good resource with a lot of YouTubes for showing how they got through all the different parts. This is more of a gamepad though than for an ORC, but definitely a great resource. Here are the different boards from ASUS. Like I said, normally it's kind of in a container in a small housing. So I've used ASUS PCs a lot in the past for powering TVs and all sorts of other things. They're great to be able to hide in the corner. And now we're just using another version with the control itself. This is the printables one that I talked about. So this goes into lots and lots of detail about how to set up this game controller. This one really looks like it's using the Steam Deck STL file, because that's the one that was there before. So there's a lot more on that than I think we generally need for what we're trying to do. Okay, so that is it from me. So let me stop presenting. Like I said, all of this will be up on the meetup group. I will put a link to the PowerPoint probably first thing in the morning or sometime tomorrow. The video has already been streamed, so that's already on YouTube, so you can see it there. And then if you look at the slides will be in all of the resources will be in the slides, so you can download the PowerPoint and let me know if you have any issues. If you have any issues with the code, open an issue on the GitHub repo and we'll fix it for you as soon as we can. And with that, does anybody have any questions?
Just a quick question about did you test the distance for the RF transmission?
Well, it depends on what radio you're using. So the
one you're using,
the Hollybro, it's pretty cheap and cheerful. So, you know, it's 400 or 500 feet. I wouldn't really risk it for anything much more than that, although I'm sure the Hollybro people would tell me otherwise.
Yeah.
But I would, you know, you could go to a micro hard and get much further distance. So probably upgrade to something like that. And you know, then you're more worried about BVLOS than you are about how far it's going to get.
Yeah.
Anything else? Okay. If anybody has any questions, shoot me a message on Meetup. Next month, like I said, we're probably going to do next month is exponential, so I want to make sure that we're not doing it during exponential week. So I want to make sure that it's probably going to be the Matrice 4E because the Intrepid.AA guys aren't available right then. But they'll probably do their ROS2 demo in June. So look forward to that. And if anybody else has anything that they want to show or want the demo, feel free to shoot me a message and I'd be happy to put.
I just want to remind everybody that I'm going to put up a slide where you can